Yes friends, so we are continuing with question number 6. As I have told you, what is the position here? There are two places P to Q. Okay, they are 162 kilometer apart. Okay, 162 kilometer apart. And now there are two trains. One train is leaving or traveling from P to Q, and other is traveling from Q to P. They are traveling opposite to each other. Alright, this is the position here. Now what does it say? That one train which moves from P to Q is traveling 8 km per hour faster than that of the train which is traveling from Q to P. This is the condition. It means speed of one train is 8 km per hour faster than that of the second train. One thing. Now after 6 hours they meet. It means within 6 hours how much distance they will travel. Okay, that is known to us. Now for the total distance, let me take the d1 distance is traveled by the first train with the speed x plus 8. Let me take x km per hour, the speed of the first train plus 8 hour. Okay, so this is the x kilometer. Or if I take let x km per hour is the speed of the second train from Q to P which is coming. Therefore the train which leaves P to Q having speed x plus 8 km per hour, because it is moving 8 km per hour faster. That's the point. I've written down here two places. They are given P and Q. P and Q, two places are given, which are two places P and Q are 160 km apart. The two trains which meet after 6 hours. The first train travels from P to Q, while the second leaves from Q to P. The train which travels from P to Q is 8 km per hour faster than the second train. This is the point given to us. Okay. Now they meet after 6 hours. Undoubtedly, it is said that they are meeting after 6 hours. This is the seventh question. No problem. Okay. So they are moving. Okay. The two trains meet at the end of 6 hours. If the train traveling from P to Q travels 8 km an hour faster than the other, find the speeds of the train. So to find here, which I have already explained here, what we have to find? To find the speeds of the two trains. The speeds of the two trains. Okay, this we have to find out. Now see the solution here. Now let me solve it. Solution. Let the speed of the second train. That is speed of the second train, which travels from Q to P. Try to understand. Q to P is x km per hour. Then the speed of the first train which travels from P to Q, B or will be, let me take will be what? X plus 8 km per hour. Try to understand this point. Why? Because this is moving 8 km per hour faster than that of the second train. So these are the two speeds. Now within 6 hours, whatever the distance they are traveling, let d1 is the distance. Let the distance traveled in 6 hours by the two trains will be 162 km. Try to understand. Why? Because they have to travel the 162 km. They are meeting in between We do not know. Now let me take the first train has traveled d1 kilometers, and second train, which is coming from Q to P, has traveled d2 kilometers. Let me write here. This we have assumed. Let again solution. Let d1 be the distance traveled by first train. Therefore, d1 is equal to the distance equal to speed into time. Try to understand. Now, speed of the first train is x plus 8 into time is 6 hours. Speed into time is equal to distance d1. This is first equation. Now, second equation will be with the train which travels from Q to P. Let me take d2, and d2, the second distance traveled by the second train is x into 8, sorry, x into 6. This is second equation. Now, but d1 plus d2, the sum of the two distances is equal to 162. Why? Because total distance d1 plus d2 is 162. Therefore, this is third equation. Therefore, from first, second and third, we have 162 is equal to 6x, this 6x plus 6 into x plus 8. Try to understand. Now let me solve this here. This implies that 6x plus 6x, 6x plus 6x plus 48, 6 8 is 48 equal to 162, or 12x, 6x plus 6x is 12x equal to 162 minus 48. Try to understand. Okay, so from this we can find out what is the value of x. X means speed of the second train. So this will be 12 minus 8 is 4, 1 carry 5, 6 minus 5 is 1, 114. 114 is the difference of these. Therefore, x equal to 114 upon 12. Let me divide it. 2 6 ja, 2 5 ja, and 2 7 ja. 2 7 ja, 14. 2 5 ja, 10. Okay, then 1 carry is 14 and 2 7 ja. So 57 upon 6. Let me find out in kilometer per hour. Will be 6 9 ja 54. 6 9 ja 54. Right, this is 6 9 ja 54. 54 and 3 carry and 3 upon 6 means 9 and 1.2 kilometer per hour. This is the speed of the second train, and speed of the first train, and the speed of the first train is equal to 8 plus this 9 and half. That means 17 and half. 9 plus 8, 17 and half kilometer per hour. So these are the two answers here. Speeds of the train are, hence let me write here. What are the speeds therefore? Therefore, speeds of the train. Therefore, the speeds of the two trains are 17.5 kilometer per hour. This is faster train, faster one, and 9.5 kilometer or 9.5 we can say kilometer per hour. This is slow train or slower train, slower one. Here are the two answers here. Alright, this is how these two questions have been done. Okay, there is no here relative speed, but just the questions to be understood, that what kind of question is given here. These are the two answers. Finally, question number 6 completed. Okay, now let us take question number 7. What does question number 7 say? Let me check that first. Okay, let me clean this. Okay, now question number 7. What does question number 7 say? Let me check it with what is given to us there. Now here we are given. 7th question says, two trains move with uniform speeds of 40 km per hour and 50 km per hour respectively towards each other. Now here it is relative speed. Okay, along parallel lines. If the distance between the trains was 50 km at 1 p.m. Right? Now find the time when the two trains will meet. Now at what time they will meet each other after? So when they leave at 1 p.m. the distance between them was 50 km. 50 km, yeah. Okay, and the speed is given to us as kilometer per hour. Let me find out what is the kilometer per hour. So total speed, because relative speed will be sum of the speeds of the two trains, because one train is coming to this side and this side, so they are coming opposite to each other. So when trains are opposite, first let me write what is the given to us. We are given here the speeds of the two trains which move opposite to each other. Opposite means coming opposite to each other. Let me take coming towards each other or move with uniform speed towards each other. Opposite to each other or towards each other. This is opposite. If I say opposite to each other, yeah, opposite to each other. Opposite or towards each other. Towards each other are, what are the speed? 40 km per hour and 50 km per hour, right? And the distance between them at 1 p.m. is 50 km. Means they are apart from each other at 50 km distance, or they are at 50 km distance from each other at 1 p.m. So after that they are moving towards each other. Okay, or when they are moving towards each other, we have noticed that at 1 p.m. the distance is remained 50 km. So this 50 km they have to meet in between, right? So what is the speed and this is the distance. When they will meet, so this 50 km is to be covered by them. What is the time taken by them to meet each other? To find the time to meet each other. Okay, now see the solution here. What is solution? The relative speed of the two trains, because they are moving towards each other, of the two trains is equal to sum of the speeds, means 40 plus 50. When they are moving towards each other, the relative speed is sum of the speeds. This is equal to 90 km per hour. This is 90 km per hour. First let me write. This is 90 km per hour. Now this is in kilometer per hour. Because 50 km is the distance. So this distance is to be covered. When they will meet, so this distance when it's covered, okay, that means they will meet each other. So therefore, time taken to meet each other distance upon speed, this is 50 upon 90, or 50 is the distance. 50 upon 90 means 5.9. If I multiply this by 60, this is now minutes. Okay, so 3, or let me take 5 6 are 30, 300 upon 9, or this is 100 upon 3, 100 upon 3. Okay, so 3 3 are 9 and 3 1 are 3, 5 6 are 30, so 300 upon 9. So this is in minutes. Okay, so what are the minutes it taken? Now let me, sorry, 90 upon 50, what I am doing here. Yeah, it is 50 upon 90, because distance upon speed. Alright, because they have to move towards each other at this speed. It will give us, now this is in minutes, because so 300, 100 upon 3 means 33. So the minutes is 3 3 are 9, 1 carry, again 3, so 3 3 are 9, 33 minutes, 33 minutes, and 1.3 again into 60 seconds. So 3 into 3 to just 60, so 20 seconds, 33 minutes and 20 seconds. Got the point? So this is the time taken by the trains to meet each other. Now if I take this 50 kilometer or 50 kilometer at 1 p.m. Now find the time when the two trains will meet. So meeting time we have to find out. When they are traveling with each other or towards each other, we can say, then this is the time to meet each other. Or if I, because time is not given, that within this time they will meet nothing. So this is the time, 33 minutes and 20 seconds after they will meet. So they will meet after they hence, therefore they will meet after 33 minutes and 20 seconds. So this was in hours. Okay, time, distance upon speed, or speed was relative speed. Okay, that's sum of the speeds here. So this is 33 minutes and 20 seconds. This is the answer, is 20 seconds. This is the answer here. Okay, so final answer is this, 33 minutes and 20 seconds. Got the point? Okay, so this is question number 7. They will meet after 33 minutes and, so anything, this is 5 upon 9. We have taken here 5 upon 9 hours. Okay, 5 upon 9 hours means into 60, that means minutes. We have converted that into 5 into 6. 6 means 3300 upon 9. Okay, that we have done. Now let us take question number 8, which is the last one. Question number 8, what is given to us? Question number 8, what is given to us? A man is standing on a platform, notes that a train going in one direction takes 3 seconds to pass him. Okay, and a train of the same length going to the opposite direction takes 4 seconds. Now how long did they take to pass each other? Means again time we have to calculate, and when they will pass each other, with the time taken by them to pass each other, the trains will pass each other. That means they have to cross their own lengths. Okay, so first let me find out what is the length. A man standing on a platform notes that a train goes in one direction, takes 3 seconds. What is the length of the train? But the length of the trains are same, I think. Okay, and to pass him, a train of the same length here. So we are given here 2 trains of same length. We are given here of same length crosses a man in 3 seconds and 4 seconds, while the trains are coming opposite each other. the trains, while the trains are coming or traveling towards each other, coming to each other, coming to each other. Okay, to find here time to travel, to what time they will take to cross each other. Okay, what the time taken by them to cross each other. To find time taken by them to cross each other. Now in this case, when the two trains are crossing each other, that means they have to travel their own distances, own length, own lengths, and the length of both are same. So suppose length is x kilometer, sorry, x meters, well, the time taken by the trains. Now undoubtedly the first train's length is 3 into x. Let me take 3 into x is the length of the train, because x is the speed, or the speed if I find out. So what is the, how to find out the total speed? Total speed means the relative speed. So let length of the train is x meters. Alright, solution here. Let length of the train, or each train, this is length of each train, let me write here, of each train be x meters, right, x meters. Therefore time taken is 3 seconds, 3 seconds and 4 seconds. It means the speed of the train, the speed of the first train will be length upon length or distance of the first train divided by time. Okay, therefore time taken, let me take, therefore the speed of the first train, will be x upon 3. This is meter per second. Why? Because it is taking 3 seconds to cross a man. Man has no length. So the train has to cross its own length. Own length is x, because both trains are of the same length. So x. And the second train, and the speed of the second train, is equal to x upon 4. Meter per second is meter per second. Try to understand. Meter per second. X upon 4 meter per second. Now these are the two speeds of the two trains. Now some of the speeds, because they are coming closer to, opposite to each other. When they are moving opposite, then the sum of the trains, speed of the trains is relative speed. The relative speed is therefore, let me solve it here. Solution. The relative speed of the trains is equal to x upon 3. This is the speed of the first train, and x upon 4 meter per second. This is meter per second. This is speed of the sum of the speeds of the two trains. Now length is x. Therefore time taken by them to cross each other. Therefore time taken by them to cross each other is equal to x plus x, length of the two trains. But they have to cross their lengths, x plus x, because they are of the same length. So length divided by sum of the speeds. So what is the relative speed is this, x upon 3 plus x upon 4. So x is cancelled out, twice x. Let me take x common here. This will be 4 plus 3 upon 3 into 4. It will be x is cancelled out. 2 into 12. So 3 4 that 12 will come in the numerator, divided by 7. It is 24 upon 7. So how much minutes? Sorry, minutes. This is seconds here. Sorry, 7 3 just 21. 3 upon 7. So 3 and 3 seconds. So this is in meter per second. Okay, so 3 seconds and 3 and 3/7 seconds. This is what we have to write here. Let me take the time. Therefore, time taken by them to cross each other is equal to 3 and 3/7. That means 3/7 is, if I just divide it, so 3.7, 4 is 28, again 2, 7, 1 is 7, so 3.41 seconds. So this is in seconds here. Okay, because speeds are in meter per second we have taken. Okay, length is meter. Okay, and time taken is in seconds, so meter per second. So speed is this. If I convert this into kilometer per hour, then also it will give us the second only. Okay, 3.41 seconds will be taken by them to cross each other. Okay, this is the answer here. The final answer is this. Question number 8 is completed. Well, here we have to find out. A man is standing on a platform, notes that a train going in one direction takes 3 seconds to pass him. A second train, the train of the same length going to the opposite direction, takes 4 seconds. How long did they take to pass each other? Means trains are passing each other. The time will be taken by the trains to pass each other. That means to cross each other. They are coming opposite each other. So relative speed, we calculate a relative speed, sum of their speeds. And first we find out that if a train is crossing a man in 3 seconds, then its speed will be x upon 3. X is the length of the train. X is the length of the other train also, because both the trains are of the same length, right? So x we assume that the x meter is the length of the train. X upon 3 and x upon 4 are the speeds of the two trains, because they are crossing a man in 3 and 4 seconds respectively, coming from opposite directions. Now therefore the relative speed, sum of the relative speeds and length which they have to cover is the length of the two trains, x plus x. So length or distance divided by speed is giving us time. So relative speed is in the denominator, sum of the two speeds, and that has given us 3.41 seconds, or 3 and 3/7 we could write. Okay, if not in point, then 3 and 3/7 seconds. This is the answer here. Okay, this is calculated. Well, then how long did they take to pass each other? How long is time? So time is to be calculated here. So that is over. Now these 8 questions are just illustrating that what is the relative speed. Relative speed question based on mostly relative speed. So relative speed is very important topic which I have to just clarify here, right? Because relative speed based on questions relative speed is very important one. Okay, so only 8 questions I am taking. Next I'll take what is the streams and boat. Questions based on boat and stream. Stream means traveling in a stream, river. Okay, and so boat is traveling in a river in quiet water, or when quiet water mostly. What is the speed of a boat just to cross it? And if the water is having some speed, then what is the time taken by the boat which is coming opposite to the stream, opposite to the movement of the stream, or going with the movement of the speed? So there are two cases. When water is silent, undoubtedly, that is the point. Then if water is having some speed, right, the stream is having some speed, then boat has to cross it from opposite direction, then its speed must be more than that of the speed of the stream, right? And if it has to be crossed with the same direction, with the same movement of the river, then the speed of the train, speed of the boat and speed of the current or the stream must be added up. Okay, so this is how, and the difference of the two speeds means boat's speed minus speed of the current, speed of the stream, is the relative speed. In this case also relative speed we have to find out, but in the second topic, second lecture series or next lecture series, I'll take streams, boats and streams, or simply streams.